We've been working in section 11.6 and working with the binomial theorem and binomial probability. The title of 11.6 is called Binomial Distributions. Specifically, we're working on 11.6 Practice A. And so this video is going to run you through the solutions to those, along with filling in some of the gaps that you may have in your notes. First, I want to remind you of our objectives. One of them is to use the binomial theorem to expand a binomial raised to a power. That's this guy right here. We'll put a bullet next to it. And then, of course, we're finding binomial probabilities and testing hypotheses. For vocab, we defined binomial theorem, binomial experiment, and binomial probability. That all took place in class, but I'm just reminding you that these are the things we're working on. Prior to learning about the binomial theorem, when we were multiplying out a binomial raised to a power, like x plus y squared, we had to consider that an x plus y times an x plus y, and then run through the distributive property twice, which we typically call the acronym FOIL for first, outside, inside, last. Right? We would multiply all these pieces, and when we did that, we'd get x squared plus x times y plus x times y plus y squared. And then we usually notice that these middle terms are like terms, and we can add them together, and we'd end up with x squared plus 2xy plus y squared. And I want to point out to you that there are coefficients here. There's a 1 in front of the x squared, right? We just don't usually write it. There's this 2 that ends up in front of the xy, and then there's another 1 in front of the y squared. And we now know that Pascal's triangle and the binomial theorem can predict those coefficients every single time. And then furthermore, we notice that things happen to these variables. So the x, which was in the first position, starts at power 2, x squared, and works its way down. Here's x to the 1, and then there is no x here because that's x to the 0 power, which is 1. The y, which is in the second position, starts with nothing, y to the 0 power, and works its way up to y squared. So there are these patterns here that we can follow to expand a binomial to any exponent, not just a 2, and quickly get that product. And that's where the binomial theorem comes in, and that's where the first part of our assignment, that's what the first part of our assignment is, assessing when we work on it. So you'll remember that we reviewed the Pascal's triangle, made the connection between Pascal's triangle and the combinations, right? Each position is a particular combination of a row and a column, or a row and a position. And they predict the coefficients for us. The binomial theorem, which we're stating down here, is the generalization of what we learned in that table. In particular, you'll notice that we can figure out the coefficients from Pascal's triangle, and then the powers of x are counting down, if you look at the exponents, n minus 1, n minus 2, and so on. And the powers of y are counting up, 0, 1, 2, 3, and so on until you get to n. And we use that pattern to multiply these things out. Okay, enough talk. We've talked about this in class. Let's get right down to the assignment. We'll check these solutions. So as you can see, I made a screenshot of the first part of the assignment. Number 1 is simply x plus y squared, and I actually already talked about that one earlier in the video, so let's just jot that one down and we'll move on. That was x squared plus 2xy plus y squared. No need for further explanation. For a plus b cubed, we need to go to the cubed column And remember that in Pascal's triangle, that's a 1, a 3, a 3, and a 1. So when we're writing this out, the coefficient on the first term is a 1, and it's going to be a cubed with b to the 0. You don't need to write b to the 0 because the value is 1. The next one's going to be that 3 coefficient. A is going to be squared because we're counting down, and b is going to be b to the first power, which we usually write as just b because we're counting up. The next one is another 3. A goes down to a to the first power, b goes to squared, and then the last term, coefficient of 1, which we don't have to write, and then the a is at 0, also a 1, we don't write it, and then b cubed. So we have a cubed plus 3a squared, b, plus 3ab squared plus b cubed for the answer. In this third problem, things are slightly more challenging because there's this little 2 next to the x. And we need to consider those one term. So whatever I did to x in the last problem, I'm going to do to 2x in this problem. And since we're to the second power, we're just dealing with the coefficients 1, 2, 1. So I just make a note to myself there. Those are my coefficients. So my first term is going to be 2x squared, which means 2 times 2 and x times x. That's 4x squared. The next one is going to be a 2 times a 2x times a y. That's 4xy. And then the last one is just the y squared, because the 2x is at the 0 power, and so it turns into a 1. So we've got 4x squared plus 4xy plus y squared. And when you get down to number 4, again, just notice this 3y is all one term. So whatever we do to the y, we also have to do to the 3. And because we're at the third power again, we're going to use the 1, 3, 3, 1 coefficients in addition to whatever this 3 happens to give us. Okay, so I'm just making a note to myself. Alright, the first term is just going to be a 1 times the x cubed. Easy enough. The second term is a 3 times an x squared times one of the 3 y's. And those two 3's multiply together, so that's 9x squared y. The next term is another 3 times just an x, and then times a 3y quantity squared. So that is a 9y squared times the other 3, that's 27. And then x was at the first power and y is squared. And then our last term is the 3y cubed. That's going to be 27y cubed. So when you're working on these, just be careful if there are extra coefficients in the terms themselves, in the first position or the second position, because we have to account for those values as well. Okay, that part looks pretty good. Let's move on to the binomial probabilities in the second half of this worksheet. So just a quick reminder about binomial probability. We need to find 4 values before we can compute this thing. We need to know n, which is the number of trials. Right, it says that right here. We need to know r, which is the number of successes that we're shooting for. That's defined right here. And then we need to know p, which is the probability of success, right? That's stated here. And q is the probability of failure, right? So those are the things we need to know. Once you know those, then you can use our formula. It's the combination CNR, or NCR, excuse me, times the P raised to the R power times the Q raised to the N minus R, whatever that N minus R value is, power. That's what we're going to use to compute probabilities for the next part of this assignment. So I'm just reminding you of that. Let's check out the problems. So in the next part, we're going to deal with tossing a coin. A coin lands head half the time it is tossed. What is the probability that the coin lands head? We know that that is 0.5 or 1/2. I'm just going to write it as a decimal because when I crank all this out of my calculator, I'll probably get a decimal anyway. So let's put 0.5, but you can also put a half. What is the probability that the coin will not land heads? In other words, it's going to land tails. That's also a half. So we'll put a half or a 0.5 in there. Part C is where we start getting into the binomial probability. So if the coin is tossed 5 times, what is the probability that it will land heads twice? So we are trying to find P of 2, if I can write it. Okay, so that means n equals 5 and r equals 2. Okay, n equals 5. Oh goodness, that's terrible. I'm not doing another take though, so you're just going to have to suffer through my mistakes. I said n equals 5 here and r equals 2, right? And then we've got our probabilities up here, 0.5 and 0.5. So we're going to do, for the computation, 5c2 times the p, which was 0.5, squared, times this is the q, which is 0.5, and we have to do 5 minus 2 for the exponent there. That's a 3. And I've done this on my calculator. I did 5c2, and that was 10, and I did 0.5 squared, that was 0.25, and I did 0.5 cubed, and that was 0.125. And I cranked that out, and it came out to be approximately, I should put the squiggly equals there because this has been rounded, but approximately 0.313. Okay? Let's see if I can highlight that. Oh, that's not great. I don't like it. I'm getting rid of it. Okay, 313. 0.313 is a probability. Little less than a third. A probability that it will land heads twice. In the next problem, they're asking us to compute P1 or 2, the probability that the coin will land heads either once or twice. And to do that, we just have to do P1 plus P2. And you'll notice we already did P2 right here. So I'm going to use that value and I'm going to add to it P1. So let's quickly figure out what P1 would be. P1, I'll do it in red and then I'll write the answer in blue. P1 is going to be 5C1 times 0.5 to the first power, because there's only one success, times 0.5 to the fourth power, because those are the failures. And I computed that already, and that was approximately 0.156. And when you add P1 and P2 together, you get approximately 0.469. That's the probability that you will get either a 1, either heads once or heads twice. Okay. And I think that's it for problem 5. Yes, it is. All right, we've got one more to go. We're doing pretty well. So for the last problem, they are reviewing a survey. The survey showed that 1 in 3 people entering the post office are wearing glasses. That tells me that the probability is 1/3, right? So I'm just going to make a note of that. My probability is 1/3 for wearing glasses. At noon, 4 people entered the post office. Yippee. Okay. What is the probability that one of those people is wearing glasses? So we want to do a P1 here. The probability that if we picked one person, they'd be wearing glasses out of the 4. Okay, so There are 4 people, so n is 4. Gosh, I'm having trouble making equal signs. And r is 1 for this problem. So we're doing a 4c1 times the probability success is 1/3, and we're going to have one of those. That's p to the r. And the probability of failure then is 2/3. And there are n minus r, or 3. 4 minus 1 is 3 for the exponent there. I cranked that out on the old calculator, and it was approximately 0.395. You might want to call that 0.40. I'm going to write 395 here. But that's the probability, if we chose one of the 4 people, that they'd be wearing glasses. Okay. Letter B says, what is the probability that one of those people is not wearing glasses? So if we pick one and the probability that it's going to wear glasses is 0.4, we'll say, to figure out the probability that it's not wearing glasses, you just subtract from 1. So we're going to just do 1 minus 0.395 or 0.4, which is going to be about 0.6, but since I'm doing the math here, this would be 0.605. If the probability that the person's wearing glasses is 0.4, the probability that they're not wearing glasses is 0.6. Okay, moving on to letter C. What is the probability that at least 2 of the 4 people are wearing glasses? Well, if we're looking for at least 2, that means we want P2 plus P3 plus P4. We got to add all those together. At least 2 are wearing glasses. So the short version of this is we do P2 plus P3 plus P4. And those calculations look something like this. To do P2, it's C42 times 1/3 squared, 1/3 to the 2 power, right, the r power, and 2/3 to the 4 minus 2, which is also 2. Then for P3, it's 4C3, and then times 1/3 cubed, and 2/3 to the first power, which is just 2/3. And then the last one is 4C4 times 1/3 to the 4th, times 2/3 to the 0, which is just 1. So I'm not even going to write that one in. I cranked all that out on my calculator, and believe it or not, I'm going to squeeze it in right here. It was approximately 0.407, or 0.41 if you want to go 2 decimals. Right around 41% probability. And then in letter D, they're asking a similar question, except this time they say, what's the probability that at least 3 of the people are wearing glasses? What I like about letter D is it actually tells us, hey, you just got to do P3 plus P4. I don't know why they didn't do that in part C for us. They waited for part D, but the idea is the same. Now, we already did the math for P3 and P4 up above, so really, I'm not going to rewrite that out again. We're just going to do, not the P2. We're going to do P3 plus P4. So same math, except without the P2. Probability of 3 or 4. And again, I cranked that out on my computer, my calculator, already. And that was about 0.111. 0.11. 0.111. 11%, give or take. Okay. So hopefully you were able to check your answers. Let me give some color to this thing and just highlight what we're looking for on number 6. This is 0.395. If you wanted to put 0.4, that's fine. This one was 0.065. If you wanted to put 0.6, that's fine. What do we have here? 0.41. And this one's about 0.11. So we've gone through the whole side A, And what I'd like you to work on now is the side B, practice B, using these same concepts. Good luck.